Okay, so welcome back to our notes for synthetic division, and in this video we're looking at example 2, which is analyzing synthetic division work to reconstruct a polynomial. So if you recall, the top row of your synthetic division work is showing you the coefficients on the polynomial in standard form. So that means that the number at the very end, that is the constant. Okay, then the next number over would be my linear term, my x, then x squared, x cubed, and x to the fourth. And so I start with the constant and I just keep increasing my exponent. Remember, a constant is x to the 0 power, linear term is x to the 1, then x squared, x cubed, x to the fourth. So my polynomial in standard form is f of x equals, and then my coefficient on the x to the fourth term is a 1, so that's an x to the fourth. There are 0 x cubes, so I don't need to write that. The 0 is just a placeholder. Then negative 13x squared. Okay, then 0 x's, so again that 0 is a placeholder for the x value. And then my constant at the end is a 36. So my original polynomial was f of x equals x to the fourth minus 13x squared plus 36. Okay, out front we see the divisor, and if the divisor was a 3, that came from a factor or a divisor of x minus 3, because remember we only use linear divisors with synthetic division. And my remainder there in that first row of division was a 0, so we know that x minus 3 was a factor of my original polynomial. So x minus 3 would be my first factor. Okay, and that corresponds to my divisor of 3. Okay, then the first term was brought down, and we multiply, add, multiply, add, multiply, add, multiply, add, and in the first row of division we ended up with a remainder of 0. Okay, then the person used a divisor on that result of negative 3, and that corresponds to a factor of x plus 3. So x plus 3 was also a factor in my factored form because the remainder of that division was also 0. Right, then I can see the result there, and the person divided into that result using a divisor of 2, which corresponds to a factor of x minus 2. And so that would go in my factored form because the remainder there is 0. Okay, then I have in my final quotient the remainder of 0, then this is a constant followed by an x, and so this quotient is an x plus 2, and that would also be, since the remainder was 0, part of my factored form. So the factored form of f of x is x minus 3 times the quantity x plus 3 times the quantity x minus 2 times the quantity x plus 2. And those are all 4 linear factors. So when I sketch the graph, all 4 of those would be crosses along the graph. So at positive 3, I have a real 0, negative 3, then positive 2, negative 2. My leading coefficient is positive, and the degree is even. And so using the leading coefficient test, we know that both ends have to face up. So when I sketch this polynomial's graph, I would cross down through negative 3, up through negative 2, then down through positive 2, and up through positive 3. And that would be 4 crosses at my 4 real zeros. So go ahead and pause the video, try B on your own, and then when you're ready, you can turn it back on and we'll go over B together. Okay, so now we're going to go over example B in the notes. And remember, the first row in the synthetic division is the standard form of the original dividend, and it ends always with the constant. Then our linear term, followed by the squared term, and the cubic term, and then this would be our first term would be x to the fourth. So the polynomial in standard form would be, since the coefficient on the x to the fourth term is -1, we'd have a negative leading coefficient, so negative x to the fourth. Then our coefficient on the cubic term is a 6, so plus 6x to the third. Then we have a coefficient of -5 on our quadratic term, so negative 5x squared. The coefficient on the linear term is -24, so negative 24x. And then the constant here at the end is a 36, so plus 36. Okay, the factors, if we notice in the work for the synthetic division, each division results in a remainder of 0. So all three of these divisors are factors, according to the factor theorem, of the polynomial. So if 3 was my divisor, then the factor that corresponds with that divisor was x minus 3. Okay, so then we have another x minus 3. And then if the divisor was -2, that corresponds to a factor of x plus 2. And then at the bottom here, we have the quotient of the final division, and the remainder was 0, so this 2 is a constant, and then our linear factor is a -1 coefficient. So this would be a negative x plus 2. Okay, and generally, when you're writing out your factors, if you have a negative term in the front, you would factor that negative out to the beginning. So we'd have a negative, and then x minus 2 would be equivalent to negative x plus 2. We factor that negative out. So our factored form then is going to be f of x equals, and we're starting with a negative as our leading coefficient, and then we have a factor of x minus 2, a factor of x plus 2, and then the x minus 3, that is a repeated factor. It has multiplicity of 2, so we're going to put a square on that factor. So when we go to sketch the graph of this polynomial using the factored form, we have a real 0 here at +2. We have a real 0 at -2, and those will each be across since they're linear factors. Then this even multiplicity on the 0 of 3 means that it's going to bounce off of that x-intercept at +3. Okay, then looking at the leading coefficient test, our leading coefficient is negative, and our degree is even. And so that tells us then that both ends are going to point down toward -infinity. So I'm crossing, starting down, so I'm going to head in an increasing direction through the 0 at -2. Then I'm going to turn and cross through +2, turn, and now it has to bounce at +3 and then head down to -infinity. So across, and a bounce, and our end behavior, both ends to the right and the left, are approaching -infinity in the y direction.